Okay, let's do practice exercise 2. Question number 11. A very simple question, but somehow people tend to get this question wrong. So I thought let me pick this question up also. Ratio of incomes of A and B is 3 is to 5, and the ratio of savings is 5 is to 3 of A and B. Whose saving is more? Now this is a superfluous data. This does not require the ratio of incomes. When I am given ratio of savings is 5 is to 3, that means savings of A will be higher than that of B. For every 3 rupees that B saves, A is saving 5 rupees. So obviously A should be the answer. But somehow this question tends to confuse people because they are probably looking at ratio of income. There is a superfluous data that is not required. But since we are on this question, let me look at another question. That the ratio of income of A and B. Let me assume that is in the ratio of 5 is to 3. Ratio of saving is also in the ratio of 5 is to 3. Then what will be the ratio of their expenditures? Okay. So if I say the incomes are 5x and 3x and savings are 5y and 3y, then the ratio of their savings, ratio of their expenditures, will be 5 into x minus y is to 3 into x minus y, or which is nothing but 5 is to 3. So if the ratio of income and saving is the same, the ratio of expenditure will also be the same. Or out of these three, if two of them have the same ratio, then the third one will also be the same. Let me take another case now. Ratio of income is 5 is to 3. Ratio of saving is 3 is to 5. And ratio of expenditure is, so ratio of expenditure, again let's do the same thing, 5x, 3y, 3x and 5y. Okay, this is for A and this is for B. So ratio of expenditure will be 5x minus 3y is to 3x minus 5y. So we do not know who's saving more, whose expenditure is more. So while here we could say very clearly, because x minus y gets cancelled out, in this particular question it may not be possible to say who out of the two A and B has a greater amount of expenditure. Okay. Let's move to the next question. Question 13. Equal quantities of 1 is to 5 and 3 is to 5 milk and water solution are mixed together. What will be the ratio of water and milk in the resulting solution? The moment question says equal quantities, you should look at equal quantities out here on itself. Now we have two ratios. One is 1 is to 5, another is 3 is to 5. 1 is to 5 is 1 plus 5, 6. That means out of every 6 liters in this one, 1 liter will be milk and 5 liters will be water. Similarly out here, out of 8 liters. But the question is about equal quantities. So 1 plus 5 adds up to 6, 3 plus 5 adds up to 8. So I will assume that let the total quantity of each of these be 24 liters. Why 24? Because 24 is the LCM of 8 and 6, and that will reduce my calculation effort significantly. So if the total quantity is 24 liters of each, so in the first one what will be milk and water? 24 means 6 into 4. So multiply both these with 4. So this is 4 into 1 is to 4 is to 5. 4 into 5, 20. And this is 8, so we multiply with 3. So 9 is to 15. So what is the ratio of milk to water if equal quantities are mixed? 9 plus 4, 13. 13 is to 35. What will be the resultant ratio of water to milk? The question is about water to milk. Water to milk is 35 is to 13, choice D. And if you notice, there is a choice A also, which is nothing but milk to water. In question of ratio, there is a very common thing you will find. If the correct answer is 35 is to 13, there is a 13 is to 35 also given to confuse you and to make sure you mark an incorrect answer if you don't read the question carefully. So question of ratios, this is important. Please have a look at this question and make sure you read the question carefully and mark what is asked. Question 14th. Mileage of a car is 16 kilometers per liter. If the fuel is totally unadulterated, if due to adulteration mileage reduces by 25%, so I can say mileage becomes 3/4. What percentage does the cost of maintaining the car per kilometer increase? Assume the maintenance cost is equal to the fuel cost. Again, what is happening out here is, because of adulteration, mileage becomes 3/4. If the mileage has become 3/4 times, the fuel required will become 4/3 times. Okay. So what you need is now 4/3 times the original amount of fuel. And what is maintenance cost? Maintenance cost is directly proportional to fuel cost. So maintenance cost will also become 4/3 times. So originally if you are spending 3 rupees in maintaining the car, now you will need to spend 4 rupees, or the extra or the increase will be 1 on every 3 rupees, which is equal to 33%. Okay. Correct answer is choice C. Okay. Again I am taking it in terms of ratio, that the mileage has become 3/4 times, that means the fuel requirement will become 4/3 times. Like, to me this is a critical item, I hope you understand this one. Mileage becomes 3/4 times, that means the fuel required becomes 4/3 times. Since maintenance is directly proportional to fuel, so maintenance also becomes 4/3 times. If the maintenance becomes 4/3 times, what is the extra required? It is 1 for every 3 rupees originally. Or in other words, if originally you were spending 3 rupees for maintenance, now you will spend 4 rupees for maintenance, or you will have to spend 1 rupee extra over and above what you were spending earlier, which is nothing but 1/3 or 33.33%. Let's move to the next question. Question 15. A candidate was asked to find 5/8 of a positive number. He found 5/18 of the same by mistake. If his answer was 125 less than the correct one, then the original number was. Standard method is, let the number be x. You are supposed to find 5/8 of x. You found 5/18 of x. This is equal to 125. Now this should tell you that your answer, or the original number, answer which is x, should be multiple of 8 as well as 18. Because we are finding 5/8 of x, so it should be a multiple of 8. We are finding 5/18 of x, so again x should be a multiple of 18. So if the number has to be a multiple of 8 and 18, the choice which is not a multiple of 8 and 18 has to be incorrect. Okay. Now look at the choices. This is not a multiple of 8. This is incorrect. 180 is again not a multiple of 8. 240 is not a multiple of 18, so that is also incorrect. So our answer in this particular question can either be 360 or none of these. Since you have eliminated 3 of the choices, let's check out what is 5/8 of 360 and 5/18 of 360 and check out the difference between the two. If it is equal to 125, that's the answer, otherwise none of these is the answer. So 18 into 20. So this is 5 into 20 is 100. 8 into 4 is 32. 8 4 is 32, then we have 40, 8 5 is 45. So 45 into 5 is 225. 225 minus 100 is equal to 125, which tallies with the data given. Correct answer is choice A. So in this question, while this is not a difficult calculation, this is not going to be very difficult, you can still save time if you just focus on the denominator. My starting point, as I said earlier, was that x should be a multiple of both 8 as well as 18. Since B, C and D, 240, 180 and 270, they are not multiples of either 8 or 18, so they have to be incorrect. Out of the remaining two choices, 360 and none of these, I verified 360. 360 into 5/8 and 360 into 5/18, it gave me a difference of 125, so that had to be the correct answer, and hence I marked the answer as choice A. Move to the next question. Question 17. An amount of rupees 680 was invested at 6% rate of interest. Another sum of money was invested at 10% interest. If the average interest on the total is 7.5%, how much was invested at 10%? So 680 rupees are invested at 6% and another sum of money is invested at 10%, such that your overall rate of interest is 7.5%. So this is a simple question of allocation. You are mixing 6% rate of interest with 10% rate of interest, such that the average is 7.5%. Or in other words, this should become 10 minus 7.5 is 2.5 is to 6, this is 1.5, or this is 5 in, okay, this is 5 is to 3. Or in other words, for every 5 rupees invested at 6%, 3 rupees have been invested at 10%. So the amount of money invested at 10%, amount of money at 10% will be equal to, it is 3 by 5 of 680. And hence your answer should be 3 by 5. You are better off if you are calculating 3 by 5 instead of 3 by 5. You should be writing it as 6 by 10, because that makes your calculation easier. Okay. So which is nothing but 68 into 6, which is 408 rupees. Correct answer, choice A. So remember this question, while there are other ways of doing this question which are lengthier, the moment you say 6% on one part, 10% on another part, such that the overall rate of interest is 7.5%, this becomes a question of alligation. Okay. Alligation is an extremely important tool which I will be using as we go along. I use it across large number of areas. Alligation cuts down calculation effort significantly and helps you come to the answer fairly fast. Please make sure you are comfortable with this concept. Question number 20. Father's age is 4 times the age of his elder son and 5 times the age of his younger son. Father's age is 4 times the age of elder son, 5 times the age of his younger son. When the elder son has lived to 3 times his present age, then father's age will exceed twice that of his younger son by 3 years. What is the father's age? Now in this question, typically we tend to get confused in these first couple of lines. Father's age is 4 times the age of elder son, 5 times the age of younger son. To make your calculation easier, assume the age to a father to be multiple of 5 and 4, or 5 and 4 20. So let me assume the father's age is 20x. So if I say father's age is 20x, elder son's age is, father's age is 4 times the age of his elder son, should be 5x, and younger son's age is 4x. Now this will help you cut down on your calculation effort. Anything else, if you say like the younger son be x, the father be 5x, and the elder son becomes 1.25x, you will end up in decimals and your calculation will become a little difficult. It is always advantageous if you write it this way. If the father's age is 4 times the age of the elder and 5 times the age of younger, the multiple or the LCM of 4 and 5 is 20, let the father's age be 20x. And similarly, you can get the age of elder and the younger son. Let's come to the second condition. These are the current ages. When the elder son has lived to 3 times his present age, 3 times his present age is 15x. Then father's age will exceed twice of his younger son by 3 years. Okay. So elder son's age has gone from 5x to 15x. So how much time has elapsed? 10x. So what happens to the father's age when the elder son becomes 15x? Father's age will become 30x. And similarly, the younger son's age will become 14x. I hope this is clear. This is the key thing out here. When the elder son's age becomes 3 times from 5x, he's become 15x. So the time elapsed from 5x to 15x is 15 minus 5, which is 10x. So 10x has to be added to the father's and the younger son's age also to get their age at this particular point of time. Okay. Now what does the question say? Father's age will exceed, father's age is 30x, will exceed that of his younger son, will exceed twice of that of his younger son. I'm sorry, it is twice. Will exceed twice of that of his younger son by 3 years. So this becomes 30 minus 28. So this means 2x is equal to 3 or x is equal to 1.5. Okay. Now you can get everything else. What is the father's age? Father's current age is 20 into 1.5, 30 years. So in this question there were two things which you had to be careful about. First, that age of father should be 20x. Why 20x? So that it becomes 4 times the elder son and 5 times the younger son. Since 20 is a multiple of 4 and 5, my calculation will become easy. I will not get into decimals unnecessarily. Second thing, when the elder son's age becomes 3 times from current age of 5x, if he becomes 15x, the time period which has elapsed or the number of years passed is 10x. So in 10x, so 10x years have passed, or hence the father's age from 20x should become now 30x, and the younger son's age from 4x it should become 14x. These were the two key things which you need to be careful about in this question, and then it is not a difficult one. Question 21. A container of milk and water. Question 21. A container has milk and water in the ratio of 3:2. The volume of the container is 50 liters. So 50 liters is the volume of the container. It has milk and water in the ratio of 3:2. 10 liters of this solution are removed and replaced with water. So 10 liters of mixture are replaced with water. Okay. What is the final amount of milk if this operation is done twice? So what you are doing is you will remove out of the 50 liters, in this mixture, you will remove 10 liters of the mixture. What is this mixture? Originally this mixture is 3:2 in the for milk and water. Once you remove 10 liters of milk and water, then you add 10 liters of water. Then you remove another 10 liters of mixture, and then you add another 10 liters of water, and this can be done many times. The question is, what is the amount of milk if this operation is done twice? Now since you are introducing water, you should be working on the basis of milk. Secondly, this mixture had 50 liters of milk and water, out of which originally 30 liters were milk and 20 liters were water. When you are removing 10 liters of this mixture, you are removing 20% of the mixture, and hence the quantity of milk and quantity of water, both of them will come down by 20%, or you will be left with 80%. So what will be you will be left with out here will be 80% of 20 for water and 80% of 30 for milk. So 80% of 30 is 24 liters of milk is what you will be left with, and 16 liters of water is what you will be left with, which adds up to 40 because you have removed 10 liters. Okay. After that you are adding water, so that will increase the quantity of water. So in other words, second time when you do the same thing, you will again remove 80% of the mixture. So what happens is, every time you are removing 20% of milk, or you are leaving behind 80% of milk. Originally the mixture has 3 out of 5 is milk. Out of total of 50 liters, this much is milk. After the first one, the quantity of milk left would be 80%, or 8 by 10 of the original. After the second operation, another 8 by 10 will be left, or rather 2 by 10 has been removed, hence 8 by 10 of the mixture has been or 8 by 10 of the mixture has been retained in terms of milk. Okay. So this is the quantity of milk which you will have after the two operations. The key thing again here being that when you are removing 20% of the mixture, you are removing 20% of milk and 20% of water, or you will be left behind with 80% of milk and 80% of water. So in every operation there will be reduction of 20%, or you will be left behind with 80%. Now since you are adding water, while some amount of water is going out, you are adding some amount of water, no milk is being added. So you can safely say every time 20% of the milk which is there in the mixture is getting removed, or 80% of the milk is being retained. So the quantity of milk finally left in the mixture will be volume of the mixture into fraction of the milk originally into 8 by 10 for the first operation and into 8 by 10 for the second operation. Supposing the same thing was repeated third time also, I would have multiplied with another 8 by 10 or another 80%. So what is the final amount of mixture? Let's just calculate that now. So this is 5 ones are 5, 5 tens are, these two go out. So 8 8s are 64 into 3, 192 upon 10. So 19.2 liters is the final amount of milk in the mixture. Had the question asked for the final amount of water in the mixture, I would have said, since the volume of the vessel is 50 liters, and 19.2 liters is milk, the remaining has to be water. Let's move to the next question now. Question 22. Gopal wants to strengthen a 15% alcohol solution to one containing 32% alcohol solution. Thus, the amount of pure alcohol to be added to 400 milliliters of 15% solution is what? Okay. You have a 15% alcohol solution. You will mix it with pure alcohol, which means 100% alcohol, such that the overall mixture will become 32% alcohol. This should be 32%. A simple question of alligation. So 100 minus 32 is 68 and 32 minus 15 is 17. So 17 ones are 17 fours are. So for every 4 liters of 15% solution, you will need 1 liter of 100% solution. Or for every 400 ml, you need 100 ml. So the correct answer here should be 400 ml. Another simple method could have been just check the choices. But I am partial towards alligation. Wherever I have alligation, I will not do anything else but go straight with alligation, because it's a very simple concept and you can apply it very fast, does not take time, you get the answers very fast. Okay, so that completes this exercise 2 also. But before we close, I'll just again highlight one thing which I think is extremely important and many people tend to miss out with respect to alligation. P1, P2 and the average. And this gives us the ratio of quantities. You have to use alligation only if you need to find ratio of quantities. Okay. If you need to find ratio of quantities, then you use alligation. If you need to find any of these things, then you use weighted average. Weighted average and alligation are reverse of each other, but doing what I have just written out here will ensure you will save time. You can do the same question by both weighted average as well as alligation. The only issue would be the time consumed. If you use the wrong method, will be higher. Both cases you will get the correct answer. That will not be a problem. Okay. So that completes exercise 2 for us.